go ahead and help you guys out with week 2 assignments. I'm going to come over here to classwork under 6 weeks, week 2. And I had stated to take a look at your notes the past few pages. We've been dealing with factoring. And let's begin with BB7. It has a lot to do with our page 36 notes, our zero factor property. Now, you'll notice in the assignment, it does state that you are to complete the section in Algebra 1. We're back into Algebra 1 again, and it's BB7, and I even labeled it there, solve quadratic equation using zero factor property. So please, do not get confused. Reading is fundamental. And if you take a look, I have assigned it to you here so it shows up highlighted. All right, now, if you take a look here, it says solve a quadratic equation using the zero factor property, and that's exactly what we were doing on page 36. If you are doing something that looks completely foreign, you probably aren't supposed to be doing it. All right? Okay, so let's go ahead and click on that. And it's going to start off nice and easy for us. Actually, the entire assignment is this easy. It's already factored it for you. It says y plus 5 times y minus 4 is equal to 0. Now, just in our notes, we had to do the same thing and split them. So I'm going to go ahead and take this one over here and say y plus 5 is equal to 0. And this over to this side, y minus 4, just making sure I wrote that right, equals 0. Now, we're going to use our inverse operation and subtract 5 from both sides. And y is equal to negative 5. Perfect. And then we're going to do the same thing, use the inverse operation, which is addition to both sides. That eliminates, I know it's been a long time since you've heard the E word. You know I don't like the C word. Y equals positive 4. Now, specifically in your notes, I wanted you to put them into a solution set, which is something that you will be expecting whenever you take your college algebra class, hopefully next semester. Now, whenever you put it into a set of braces, you're going to put it in ascending order. That means least to greatest. So that would be negative 5, 4. Now, you're fortunate because IXL is so nice and easy to you, and it says, oh, just type it on in. Boo, you're good. So there we go. And 4, submit. Wow, it's that easy, miss? Yes, it truly is that easy. I love you. You're welcome. All right, we have r minus 3 and r plus 1. Okay, now if you guys don't mind, you see I got a little boo-boo here, so I'm not going to switch markers. Let's do r minus 3 equals 0, and then r plus 1 equals 0. I know that a lot of you guys should already, again, this is nothing new, you should start to see what the trick is here. Do that trick, all right? What's the trick? I don't know. I'm going to let you try and figure that out. Come on now. So I said I wasn't going to, but here I am. All right, I use the inverse operation, so r is equal to positive 3. And here I'm going to use the inverse operation again. And this time, r is equal to negative 1. My solution set, negative 1 is least, positive 3 is greatest. This is not a coordinate. These are two x-intercepts, so since this is positive here, that means that it crosses at negative 1 and positive 3. All right? Those are the solutions. So let's write it, negative 1, and then tap that over, 3. Love it. All right. Now, you'll notice this is moving a little slow, huh? So we have c plus 5, c plus 2 is equal to 0, c plus 5 is equal to 0, and then c plus 2 is equal to 0. All right. inverse operation, minus 5 minus 5. C is equal to negative 5, minus 2 minus 2. C is equal to negative 2. All right, let's type that in. Negative 5 and negative 2. All right. It's going to keep us going until we get at least a 70, all right? W plus 8, or minus 8, is equal to 0. See, I'm getting lazy now. W plus 2 is equal to 0. Okay. This is a darker color, so I don't mess that one up. Inverse operation would add 8 to 0 that out. W equals 8. And inverse operation is to subtract 2 from both sides, and W equals negative 2. Now, does it have to be put in this order? No. As a matter of fact, you could put it in correct ascending order, and you would still get it right. You can also have backwards, and it's not going to count it wrong. Now, here we go. So, you guys probably saw the trick there on all of those. It was pretty much whatever the factor was inside the parentheses, it was the opposite. Now here, it's not always the case, so you really want to be careful with these, because this time I have a coefficient in front of my variables, so I'm going to write this one all out. The second factor is 7t minus 8 is equal to 0. All right. 5t plus 7 is equal to 0, and 7t minus 8 is equal to 0. I don't mind using a little bit of color here. So, whenever you're solving, remember, you must remove the constant first, using addition or subtraction. So I will use subtraction to remove my 7. I have eliminated it. That leaves me with 5t is equal to negative 7. Ooh. Now, 5 and t are being multiplied, so its inverse operation is division. 5 divided by 5 reduces to 1. That leaves me with an answer of t is equal to negative 7/5. Perfect. Let's do the same thing here. Now you'll notice that your constant is now a negative 8. So to eliminate it, I am going to use the inverse operation of addition, because that's a big fat 0. Now 7t is equal to a positive 8, and divide both by 7. That reduces to 1, leaving you with t is equal to a positive 8/7. Now, these look nasty, yes, but just because they're ugly doesn't mean anything. Oops, dang it, I typed the wrong thing, so that's on me. Let me move on to the next one. I accidentally typed the wrong thing. So, 1 second. Actually, I'll just show you. Like I said, this factor here, you could always think of this as, since it's 1d minus 8 equals 0, since you're going to do the inverse, that would be your answer, positive 8. The inverse here would be positive 7. So let's type that in. 8 and 7. Okay, so yeah, you can totally use that on those, but just like I said, like the example that we have here again, hopefully I'll write it correctly this time, you can't do that. You have to do the actual work. So, let's write that out. I'm going to erase my crescendo. All right, so I have 4z plus 5 and 6z minus 5. All right, now, please be very careful. Even with your own work, you guys always mess up. especially when you're copying, cough, cough. You might want to try practicing putting a little dash in between those z's, because if not, they look like 2's. All right, so remove the constant, which is positive 5 by inverse operation, subtracting 5 from both sides. 4z is equal to negative 5. And then since they are being multiplied, you divide, which is the inverse operation, both sides by 4. That reduces to 1z is equal to negative 5/4. Okay, I think I'll type that in before I function up again. Negative 5 divided by 4. Let's do the same steps over here on the right side. Now, this time, my constant is a negative 5. So the inverse operation is adding 5 to both sides. That eliminates, leaving me with 6z is equal to 5. Once again, they are being multiplied, so the inverse operation is division. 6 over 6 reduces to 1, and you're left with z is equal to 5/6. All right, so let's write that in. 5, almost did it again, 6. All right. Now, this next problem that you have is kind of nice because it gives you a little bit of both. So it gives you an easy factor, g plus 7, and it gives you a harder factor of 5g minus 4. All right, well, the g plus 7, that one's ridiculously simple, isn't it? Leaving you with g is equal to negative 7. But then we have 5g minus 4 is equal to 0. Let's remove my constant by adding 4 to both sides. Eliminates. 5g is equal to 4. Let's reduce this. Reduce to 1. And then g is equal to 4/5. Hope to God I write this correctly. There we go, negative 7 and 4/5. There we go. All right. I'm getting a little lazy here, so I don't feel like rewriting it, especially because it's right there. So I'm going to take my first factor, which is 8p minus 3. Again, be careful with those p's. Equal to 0, and then p plus 1 is equal to 0. Well, that's just easy. I see that I should end up with p is equal to negative 1, which is the opposite of what the original factor was. But here, I need to remove my constant by adding 3 to both sides. And bring down 8p is equal to 3. And then removing my coefficient of 8 by dividing by 8, reducing that to 1p is equal to 3/8. So 3/8 and 1. Oh, I forgot to write the negative. Oh my goodness, I'm going to be stuck on this forever. Oh, sorry. All right, so actually, happy chance, I got something that I did want to discuss with you. This one says n times n minus 9 is equal to 0, and it looks weird. It doesn't look like my other problems. Now, the reason it looks weird is because if I were to add these parentheses, have I changed anything? Well, no. As a matter of fact, right now, I could just immediately do my zero factor property and say n is equal to 0 and n minus 9 is equal to 0. Well, I don't have anything to do over here, so that's n is equal to 0. Here, I can add 9 to both sides, leaving me with n is equal to a positive 9. Oh, goodness. Made a silly mistake there. So let's put 9 and 0. Okay.
I'm actually going to just skip this real quick so I can get onto a harder problem. Okay, this one isn't harder, but it's just a little different, so I thought I'd go over it. Here I have f times 2f minus 5 is equal to 0. So, of course, I could say f is equal to 0. Now here, I have 2f minus 5 is equal to 0. Just slightly different from what we had to do before, but not really, because of course I would get rid of my constant by adding 5, the inverse operation, and that leaves me with 2f is equal to 5, and I should also get rid of my constant by dividing both sides by 2, coefficient. That reduces to 1. F is equal to 5 halves. Okay, so put that in here. 5 halves and 0. Perfect. Now, this one again, not difficult, just a little different. So I'm going to write this out as 6c is my first factor, it's equal to 0. My second factor is c minus 8 is equal to 0. Now here I don't have a constant, all I have is a coefficient. Now since they're being multiplied together, the inverse operation would be to divide. The thing is, 0 divided by anything, it's still a big fat 0. So it really didn't change anything. That's why I was saying it's not any more difficult, just a little different. And of course I would add 8 to both sides, leaving me with c is equal to positive 8. So that's going to be 8 and 0. 0, 8, doesn't matter. Now, from this point forward, it really is just as easy all the way across. So my first factor is k minus 3 is equal to 0, and 3k plus 5 is equal to 0. All right. Add 3, that eliminates, k equals 3, subtract 5, 3k is equal to negative 5, and then of course, divide by 3, there we go, k is equal to negative 5 thirds, okay, negative 5 thirds, and 3. All right, it's going to be that easy all the way through. I'm going to stop here though so that I can help you with the other one. So F.8 is solving a quadratic equation by factoring. You may want to refer to page 35, which was our factoring flow chart. Page 35, the one that I left in my classroom that I cannot get to. So, I bookmarked it here. That this is our flow chart from one of my old classes. So here, always begin with, is there a GCF? Now, in our case, well, no, we don't have one. As a matter of fact, we have here is m squared minus 12m plus 20 is equal to 0. So there is not a GCF. Is it a binomial or trinomial? It's a trinomial. A is equal to 1, so therefore we get to use trial and error, which was the previous page, page 34. Now remember, you can do your puzzle pattern boxes if you'd like. Remember, up here is C, down here is B. So my C is a 20, my B is a negative 12. I'm going to look for all of the factors of 20, starting with 1 times 20, 2 times 10, 3, no, 4 times 5, and well, 5, that's it, we're done. Now, you have to see which of these will add or subtract to give you negative 12. Now, the only ones that will give you negative 12 would probably be a negative 2 and a negative 10 adds up to give you negative 12. So negative 2 minus 10 gives me negative 12. And they also multiply to give me a positive 20. Now, the thing is that now you have it factored. So that would be m minus 2 times m minus 10 is equal to 0. Now you have to apply the zero factor property. That's why this one takes a little bit more to do. So here you factor and you would say m minus 2 is equal to 0, m minus 10 is equal to 0, but these were the easier ones that we already knew. Oh, well, duh, just, it's going to be the opposite, so plus 2. And less 10. And you can go ahead and type that out here. Like that. All right. Now, we went from an easy one to one that's even easier. So we have d squared plus 40d is equal to 0. Remember, first and foremost, you always, always, always ask yourself, is there a GCF? Duh! What do they both have in common? D. So let's factor that out. So that would be d times d plus 40 equals 0. Now that's where you've got this nice and easy, because here you would write d is equal to 0, and then d plus 40 equals 0. Well, don't have to do anything there, but here you would subtract 40. So d is equal to negative 40. And let's go ahead and type that on in here. 0, comma, negative 40. Now again, I didn't put that in ascending order, so don't worry. Awesome. And that's pretty much what you're going to be doing all the way through, so I'll do as many as I can here. Alright, so g squared plus 9g plus 18, man, they are so nice to you, because do you have a GCF? No. Is this a binomial or trinomial? Trinomial, and a is equal to 1. So, boo, this is easy. Do you have to draw all this out? No. Am I gonna? Just for you. So that's 18 and positive 9. Factors of 18, that's 1 times 18, 2 times 9, 3 times 6, there is no 4 or 5. Which one of these will add or subtract to give you 9? Well, that's addition and addition, so that's positive 3, positive 6, g plus 3, g plus 6. Now remember that little like quick easy thing that we noticed, the pattern with BB7? Yeah, you just take this and get the opposite of it. So that means that that would be negative 3 and that would be negative 6. I don't want to waste time. If you want to put it in ascending order, you can also do that. Oh, look at that, another nice and easy one. You know what, I'm going to skip this, see if there's any more difficult problems here. Honestly, this one isn't too much more difficult, but it's different from the other ones that we've done, so I'll go ahead and do this one with you guys. 10k plus 24 is equal to 0. Alright, so I want to try and find what will fit into my box here. If I have a positive 24 here and a negative 10 here, so factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Well, I guess it really wasn't that difficult, right? Because that's a negative and that's a negative. And negative 4 minus 6 gives me negative 10, and it multiplies to give me a positive 24. Oh, this one was actually easy. I'm sorry. I didn't mean to waste you guys' time. K minus 6 is equal to 0. So, using the inverse operation with both, there we go. I would say K minus 4 equal to 0. K minus 6 is equal to 0. So therefore, plus 4 plus 6, K equals 4 and 6. That in here. Alright, yeah, let me find one that's a little bit more difficult. Alright, here we go. This one's a little bit more difficult. So, taking a look, is there a GCF? 6, 5, and 4 do not have any other numbers in common other than 1, so I'd say no. It's not a binomial. It is a trinomial. My leading coefficient is not 1. So that means I would want to be following the factor by grouping model. I'll have kind of side by side if my desk will allow. There we go. All right. So, here we go. We're going to go ahead and multiply 6 and 4. Sorry. Identify your A, B, and C. So that is A, B, and C. Again, this is all stuff that we've gone over before. So multiply A times C, that is negative 24, but I want factors of the absolute value, so don't worry about the negative. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now I'm going to take these and I want to use this little matrix here. So my C is negative, my B is positive, and it says the bigger factor will be positive. You know what? I'm just going to take care of that right now. So that means all of these are negatives. And these are positive. Which of these is going to give me 5? Oh. This one right here. Okay. So let's go ahead and rewrite. So that means I should write 6p squared minus 3p plus 8p minus 4 is equal to 0. Okay, so now we split it down the middle. Let me scooch that over a little. Okay, there we go. Split it right down the middle here. And we start factoring. So what do both of these have in common? Well, they both have a p in common, duh. But they also have a 3 in common. So I'm going to pull out 3p. And that should leave me with p minus 1. Now, if that's the case, then that means over here, I should also have p minus 1. And, well, yeah, that makes sense here. Oh, wait. I made a silly mistake. Because 3p times 2p, there we go, gets me 6p squared, and 3p times negative 1. Okay, so I should have a 2p minus 1. So what goes in the blank here? Well, that would be 4p. A positive 4p. times 2p would give me, oh, okay, positive 4. Positive 4 times 2p would give me positive 8p. 4 times negative 1 gets me negative 4. So these two come together, and that says 3p plus 4. Now we have the exact same thing inside of those black factors, which is 2p minus 1. All right. Now this one was a little bit harder, and that was just the first part. You now have to solve. So 3p plus 4 is equal to 0. Do the exact same steps here. We're going to subtract 4 to remove my constant, leaving me with 3p is equal to 4. And now, once again, I know it looks ugly, I get it, but same steps, and it's not that bad. Divide by 3, reduce to 1. P is equal to 4/3. And here, 2p minus 1 is equal to 0. Well, I add 1 to both sides. That eliminates, leaving me with 2p is equal to 1. And of course, inverse operation, you divide by 2. That reduces to 1, leaving you with 1p is equal to 1/2. Whew, okay, so let's go ahead and type that in here. So 1/2 and 4/3. Oh dear, 1 second. Oh, I'm all sorts of upset at myself. This is why I like having you guys here, because I didn't see this silly mistake here. I had a minus here, but I didn't put a minus there. Dang it. Okay, well, let me go ahead and get through the next one then. 1 second here. Okay, so once again, I do not have a GCF. I have a trinomial, and a is not 1, so factor by grouping. We'll take these two and multiply, and that should give me 26. So let's find all of the factors beginning with 1 times 26, 2 times 13, and well, that's it, which is nice. All right, and obviously, if we take a look at our matrix here, there we go, sorry, our C is negative and our B is negative, so our bigger factors will be negative. All right, so there we go. Get that out of the way. So let's put negatives here, and that means these are positives. And well, yeah, that was kind of what I was looking at anyway. So 2v squared plus 2v minus 13v, and then minus 13, again, equals 0. So let's split it down the middle. All right. Now these two have, well, 2v in common. Leaving us with 2v times v is 2v squared. And 2v times 1 gets you 2v. So that means on the inside I should have v plus 1. Well, the only thing I could do is say that negative 13 times v is negative 13v. Negative 13 times 1, there we go, perfect. So that should be 2v minus 13, and v plus 1 is equal to 0. Now, this one is the really nice and easy one, isn't it? So let's go ahead and take a look at that one here. Because, let's see, 2v minus 13 is equal to 0, and then b plus 1 is equal to 0. And here I just need to remove my constant by subtracting 1. Subtracting 1. Hopefully I don't make that same mistake. V is equal to -1. Just double checking myself again. Now here, I want to remove my constant by adding 13 to both sides. Adding 13 to both sides. Leaving me with 2v is equal to 13. And then, there we go, we would divide both sides by 2. So v is equal to 13 over 2. Pop the 13 over 2 and -1. Oh goodness, I better type it correctly. -1 and 13 over 2. There we go. Ooh. Now this one is a little different. Let me erase. Alrighty, so taking a look here, 50x squared minus 33x, they do not have a GCF. It is a binomial, but taking a look at page 35, if it's a binomial, you would want to double check to see if it was a perfect square. If we had this situation happening here, the difference of squares, which we do not in this case, because 50 is not a perfect square, neither is 33. But they do both have x in common, so let's go ahead and factor that out. I'm sorry. They do not have a numeric GCF, but they do both have x in common. So that leaves me with 50, then x minus 33 is equal to 0. Now, taking a look at 50x minus 33, this does not have a GCF, nor does it fall into a difference of squares. So, let's just begin to solve. This one is easy. X is equal to 0, and then 50x minus 33 is equal to 0. Always remove your constant first by adding 33. Adding 33. So now 50x is equal to a positive 33. And, of course, divide by 50. Leaving you with x is equal to 33 over 50. There we go. So let's go ahead and type that on in here. We have 0 and an ugly fraction of 33, positive 33 over 50. And looks like I can do this one last one with y'all. Well, it kind of looks the same. Let me check to see if they have a harder one. How about I do one last factor by grouping with y'all, and it looks like that's going to be the hardest that you guys have. So that's 2d squared plus 25d minus 13 is equal to 0. They do not have a GCF, either numerically or with variables. So I'm going to take my a and my c, which is negative 26, and find the factors from the absolute value, which is 1 and 26, and 2 and 13. According to the matrix, my c is negative and my b is positive. So that means the bigger factor will be positive. The smaller one will be negative. So, which one of these gets me 25? There we go, that one it is. So let's go ahead and rewrite 2d squared minus 1d plus 26d minus 13 and equals 0. Alright, we have 4-term polynomials, so let's go ahead and split it down the middle. And both of these have, well, d in common, so let's factor that out. Gives me 2, sorry, use a different color, 2d minus 1. So that means over here I should also have d minus 1. Now, oh, sorry, 2D minus 1. There we go. Now it should make sense, because if I put here a positive 13, 13 times 2D, that gives me positive 2060. 13 times negative 1 is negative 13. So therefore, I have D plus 13 times 2D minus 1 is equal to 0. Zero factor property. Let's remove my constant by using the inverse operation. D is equal to negative 13, which is the opposite of what I have inside as my factor. Again, remove my constant by using the inverse operation of addition. 2D is equal to positive 1. And then use the inverse operation to remove the coefficient by dividing by 2. So therefore, D is equal to 1/2. Now, something interesting is you do not always have to put in fractions, because I know that 1/2 is simply 0.5. So I could put in 0.5 and then comma my negative 13, which is not in ascending order, but all right. Oh, scratch that, never mind. So apparently it does want it. Good thing I did that. Usually it's perfectly fine with decimals. So in that case, definitely keep it as a fraction. Learn that one the hard way. And you will get to a 70, unlike what I just did right now. And do I need a break? Yes, I do, because I just finished recording too many hours of this. Now, if you guys have watched this video and you're still feeling stuck, I am going to have Working Wednesday tomorrow. And I'll try doing that on YouTube Live. Nobody answered, so I really didn't want to go online. If there's a specific time that is later, I don't mind doing the YouTube Live later if I can capture a lot more of you guys and answer more of your questions. So please take a look, try it out. Let me know if you still need some more help tomorrow. Hopefully I'll see y'all then. Bye.